randomly chosen rock climber. That means I really picked randomly. No, because if I picked randomly, everything would be possible. But this is randomly filled with pictures. Okay, so that means I process those two. Yeah. So I want you to see if you can get those four answers. This is just a practice test question. Classes on Monday. And we'll talk through how you would do this in a moment. I'll need a calculator. If you want to borrow your money, come up and leave me some collateral. But I would really appreciate it if you would get you going. it makes me wonder if, I don't even think this is actually right. Okay, good. So then if you do have a mistake, it probably is a mistake. Yours is different than this. Okay. Any questions? Okay, moving on. This was our, if I could just double check this against this, 8, 4, 3, 5, 9, 6, 12. 6, 12, yep, good. Okay. And then, this is that probability one. And these are pretty easy. Let's just do the first one here. What's the probability of a randomly chosen person has a cat or a phone? Cat or phone? Because I wouldn't have the cats and phones. That's a smarter way. I mean, cats and phones together is what we're doing. But that's a smarter way than adding all those numbers up. Some of you know what I'm getting at there. Okay. If you know how it works, are you supposed to be big answers or small answers? You want big answers. Because you know if it's this or this or this or this, you have them all. But yes, four, random letters. Okay? Now, since that adds up to 100%, let's pay. That's a faster way. One minus these two. Okay? And then five, 7, and let's subtract 7, 8. It's just faster than adding 1, 2, 3, 4, 5, 6 numbers together. Not tons faster, but it's a little faster. So you can do 100% than those two numbers we didn't use. So I take 1 minus those two. And just that. 6, 8, 6, 4, 6, 8, 7. Uh-oh. Let's make sure that there's no chance that we're making a mistake here. We'll pause for a second and type it in the calculator. Okay, so the rate is actually 0.764. Mistake in the included. There, talking about that kind. Let's move on to making an expected value. Every single time we can expect 100%. The probability tree. Okay? And your expected value is the probability tree, and we're going to take the probability times an amount. It can be either money, if it's like a dollar's per, like this one is, or it could be if it's children or kids shooting baskets. It could be how many dolls they're making or how many kids they're having. But this is how much amount. The probability will be times by zero, so typically we'll just simply add the math. Then if there's a cost for playing the game or a cost for each entry or whatever, then, like in this case, the protection plan cost, that gets subtracted off at the very end. Alright? Which is so you can handle this one. Imagine if this was today, and it's all going to work. That's your point of mistake. Just put it up on top, because just so we don't have totally different answers to what matter. And for the probability that it's going to work or that it's going to break, and they'll usually tell you something that'll give you a fraction for that. That's your secondary try. Okay, so this one, probability that's going to work. Let's say I can realize here, but 3 or 200 break. I'm going to use that nearly, no, I'm not nearly 7 out of 200 must work then, because these are complements of each other. But now, if I take the probability of it works, I don't get nothing if it works. That's the point of the warranty, is if it works, you don't get paid anything. If it works, you should get paid something. And in this case, it covers the cost of the flight, which is $100. So then, we multiply the 2 times the option 0 is going to this because we multiply to get 0. And this way, times by 100, we are going to get, let me think, cancel this out. Let's say that in this case, this is only left. I'm going to use a minus adding up is a buck 50. What will I have to turn in yet, though? Right? Because if, I didn't do this right. It's 3 over 200 times 100 is actually a buck 50. Did I get that right? Okay, because I saw some people looking at it funny, so I'm like, What is it? 1849? Okay. So that is, and lose 1849 average. If you know either one day because I got $100 and I only paid $20 for this warranty, or one is big and it's putting in a warranty and I get nothing. But the average I would lose. Yeah? It's not surprising to lose because I make a profit, but it's a lot of profit. I was really worth about 50 and I paid 1849 for it. So that's a pretty standard deal. Now, branches are big. I won't say that because it depends. If you can figure out, I'm more likely than the average person to actually use this warranty, then you bring the chance why it's a good idea to buy it. Yes. Yep. So you're supposed to lose 1849 and you're supposed to gain 1849. Exact opposite. Okay. And to work. Yeah. So this is a probability question. It's answered in expected value. Let's see. And it's first two probabilities, and the last one's an expected value. So this one you never have to do with me. Good practice. Very typical. Like the question that's expected value, it's not normal. Okay? So we have okay and L. Just to make if the same as being able to be careful for a simpler. And it's a 3-day week, so it's going to be a family check. Take a minute and recreate this. Chances being able to is 0.495. That's pretty sad. 495 and 0.495. And then obviously it's there the number that goes with that. Complement of it, take one notice, the 0.495. Maybe 5 or 5, I think. Okay, so I took a minute. That is a typical probability pattern that you have to know how to do. You make a big old chart. You have to probabilities. If you have an expected value all notes, but if what we have to know what we're looking for here is the expected value does vary over time. So the notes that we're considering is in times. In this case, it was 3 times. In this case, it was 2 times. In this case, it was 2 times. For this one, it was only 1 time. And we have 1 time again. Should I tell you something? Alright, alright. Last 2 times on this one. And I think I put it above it, so. Oh boy. Hold on, I'm going to undo. There we go. There's a 2. This one's a 1. This one's a 1. And this one is 0 on times because they're right. Okay. So that tells us what to multiply our p's times our a's, and then we add them all up. What is interesting, again, you have to plot, so there's no subtracting anything at the end. You just get its own total at the end. Alright, so let's see here. It's a good idea that the answer is exactly 2 out of 3 days. We're able to look and see which of my things are able to be exactly 2 out of 3. This first one is not exactly 2 out of 3. It's 3. This one's able to do twice. And this one is able to do twice. This one is able to do twice. And I think those are the only 3. Is that correct? That's literally 3,024,60, 72.372. Now, credit depends on what you're labeled to. Oh, we got 0.372. Alright? Now, what's the out of it right exactly 1.5 days. And the question was asked, and I got it down, is not the same thing. Well, asked about when they had time in exactly 2 out of 3 days. Isn't that the same as being right once? Just ask this question. If you're on time twice, and you're right once, isn't that the same as being right once and on time twice? That's seriously. Now, it's actually look and see if it's a probability that's the same. Okay? So what's the probability of that exactly 1.5? Look, let me see. Which of these right 1 out of 3 times? Would you agree this is right 1 out of 3? Is my other iteration right 1 out of 3 times? Okay. And the other is, yeah, I think it seems like the same to me. And right exactly 1 out of 3 should be the same as on time exactly 2 days out of 3. And it is. Alright, good catch. Maybe I'll be faced with people saying you're wrong, you stuck to it. Alright. What is the expected number of days that will be on time? Okay. That's the one where we did 3 times the longitude one. You know, this is how we, this is the amount. This is the quantity of the amount. This is the amount. This is the amount of times here. When we put that all together, we're expecting to be on time about 1.5 days. Now, that can't really be on time 1.5 days, right? It can't be half on time. You're in that time. So we're expecting to be on time at least 1 day out of the 3 days. And in fact, it's definitely closer to 1 than it is to 2. So we would definitely expect it in the real world to be on time once out of the 3 days. Anyway, big deal in the real world. You don't want to be late. At least, if you're not rules, people have forgiveness, but if you're on time, people get really ticked at you. And in some places, you're just have no time for you at all. And, you know, different places have different rules, but in the military academies, one of their sayings is, if you're on time, you are late. If you're early, you are on time. And if you're late, you are forgotten. As in, like, that will actually make you, you like the class, like, you like the class once, that'll make you run around the playground with your rifle for hours, just like once. It's like a really big deal. So anyway, it was really not being good things like that, but being on time in the business world, when you like to a meeting, it's like being disrespectful to all those people that you're in a meeting with. It's like you're wasting their time. So anyway, that's one thing you could try to work at to become a better person, at least in our society in the United States. We really value being on time. But there are some places that we get on time. Probably heard of that, right? We're in the Caribbean or whatever. One time is really like, deciding that I have 2 o'clock. It's like, really 2 o'clock. Like, I'll be there before 3 is what that really means. So, there's different places that have different kind of standards, but getting lost times are kind of a big deal. So, how much do you want to do for